Yo, what's up everyone? Welcome back. Patrick here. Moving on to the next video. We're now going to talk about the revenue versus marginal revenue function. We're going to dig into a little bit more detail with how both of these functions relate. So let's just start off in general talking about revenue. Now, revenue, as we know in general, it's basically equal to the number of units sold of whatever product that you're producing times the price per unit. That's going to give you the total revenue. So if you're selling a product for $5 per unit and you sell 1,000 units, then your total revenue is going to be 5,000. So pretty simple there. Now what happens is usually this number of units sold, it's represented with a variable. Let's call it x. So if we let x be the number of units sold, then what's going to happen is this bracket here is going to be x. Now, what happens in the real world is usually this price per unit, it actually doesn't stay constant. It actually changes, and it has a relationship with x, with the number of units sold. Sometimes you'll see this called the quantity as well. Right? So this is going to be variable, and it has a relationship with the quantity, with the number of units sold. So for this bracket, what we can do is we can create a function p, let's say, and that's going to be p of x, like that. Right? So the revenue is equal to x times p of x, right? The price is a function of x, of the number of units sold. So sometimes you'll see this called maybe a price function. Sometimes you'll see this called a demand function. If you remember from economics, if we expand on this bracket here, basically p of x, so p, the price, is the dependent variable, and then x, which is the quantity or the number of units sold, is the independent variable. And if you remember from economics, price and quantity sold usually have an inverse relationship in most cases. Sometimes you'll see it represented as a curve, right, a demand curve. Sometimes you'll see it be represented as a line. I'm just going to represent it as a line in this case, right, just for simplicity, like that. Usually, most cases, there's going to be an inverse relationship, right? The law of demand, as the number of units, as the quantity sold increases, the price decreases, or vice versa. As the price increases, the quantity sold is going to decrease. And so what you'll usually see is this price function. It can be given as different types, but a common way that it's represented is with a line that has a negative slope. So if we do an example, let's say that maybe, so we have this x over here, and let's say that we have a demand function or a price function given as a negative 0.04x plus 800, like that. This is a very common type of format that you'll see for this demand function, and it makes sense. It follows that law of demand, because notice that the slope, right, this is a line here, the slope is negative, has a negative slope, and then that b value is positive, or that y-intercept, which is like up here, is positive. So that's a common format that you'll see for the demand function. It could be given in different formats. You might even get a quadratic sometimes, or a cubic. In this case, let's just keep it as a line, like that. And so if we roll with this example, so the revenue function, let's call it r of x, is going to be this basically, and if we expand it, we can say it's negative 0.04x squared plus 800x. like that. So if they give you a demand function, which would be this bracket over here, or a price function, and they ask you to give a total revenue function, you would take that price function or that demand function, which is the price per unit, and then multiply it by the number of units sold, by the X, and then you end up with your revenue function. Right, so I'm actually going to take this, I'm going to write it up here, save some room here. So that's the total revenue right there. Now, what's marginal revenue? So if this here is R of X, right, the total revenue, well, marginal revenue is just going to be the derivative of that. And so if we take the derivative of this, apply the power rule here, so we'd have negative 0.08x, and that's going to be plus 800, like that. So this is the revenue, this is the marginal revenue over here. Now, what is the marginal revenue representing? Intuitively, just in words, well, it's basically, I'm going to describe it in different ways here, it's basically the rate of change of the total revenue, or of revenue. All right, so it's basically how much revenue, total revenue, is changing for an additional unit sold given that current sales is at X units. Right? How much revenue is changing for an additional unit sold given that current sales is at X units? So let's say that the current sales is at 100 units. Well, if we plug in 100 over here, that value is going to be how much the total revenue is changing from the sale of the 101st unit. So another way to describe this is the change in total revenue from the sale of the X plus 1, let's put X plus 1th unit. All right, this is pretty important because sometimes they'll ask you to interpret these results. So these are different ways to describe, and I'm going to show you numerically how this works, but it's basically how much that total revenue is going to change from the sale of the next unit. Right, so given that sales is, let's say, at X units, right, so let's say it's at 100 units, if we plug in 100 over here, that value is going to be how much the total revenue is going to change from the 101st, from the sale of the 101st unit. So let me show you with numbers what I mean by this so you don't get confused. So let's take that example with 100. So if I find R prime of 100, okay, if I plug in 100 over here, what I'm going to end up getting is 792. So what this means is that total revenue increases by $792 from the sale of the 101st unit, from the next unit after 100. And if you want to see in more detail how this works, what we can do is see what the total revenue is at 100 units. So we would plug in 100 into the total revenue function. And when you do that, what you're going to end up getting is 79,600. That's going to be the total revenue if you sell 100 units. And then what you could do is you could figure out what's going to be the total revenue if we sell 101 units. If we plug in 101 for this, you're going to get a decimal number, but if you round it, what you would end up getting is 80,392, approximately, if you round it. And so the revenue went from 79,600 to 80,392. What's the difference between that? The difference is going to be 792, which is this amount right there. Right? So that's what the marginal revenue is giving you. It's giving you the change in total revenue from the sale of the X plus 1th unit, the additional sale of that X plus 1th unit. Now the reason why, this is actually an approximate number because this was actually a decimal and we just rounded it. In fact, what's happening is that this value, it's actually not the exact change from 100 to 101. It's more so the change from like 100 to something very close to 100, like 100.00001. Right? And this pretty much goes till infinity if we get really abstract here mathematically. But we're just assuming that you can't produce that small of a unit. Right? So we're looking at whole units, so we're going from 100 to 101. And so that's why this here is actually an approximation to how much that total revenue is going to be changing. But usually when you're dealing with big enough numbers and you round to the nearest dollar, this amount should be fairly close. Now, that's basically what the marginal revenue means. So if they ask you to interpret, let's say a test asks you to interpret, what does this mean over here? It basically means the change in total revenue from the sale of the 101st unit. The change in revenue from 100 units to 101 units. That's why I wanted to go over this. Now, there's actually other uses for marginal revenue. We can also use it to find out when is revenue, the total revenue, going to be maximized. And we can actually maximize revenue when we find out when the marginal revenue is equal to 0. Right? So you can actually graph this over here. So if we graph the marginal revenue function, notice that this is just a line, right, with a negative slope. And so the line, it's starting at 800, and it's going to go down like that. Now, what's this here going to be? Well, that's going to be the x-intercept. So it's basically when that marginal revenue is going to be 0. And so when we isolate for x, we would end up getting 10,000. So this here would be 10,000, like that. And so what this is telling us is that the marginal revenue is equal to 0 when x is 10,000. And that tells us when the total revenue is maximized. So if we took the total revenue function and we graphed it, notice that this here is a parabola. And if we were to factor it, so if we were to like factor out a negative 0.04x, we would end up having x minus 800 divided by 0.04 would give us 20,000. Right, so if we take this quadratic and we factor it, we would end up with that there. Right, so now we're going to be graphing the revenue function. So notice from here, what are the two intercepts? 0 and 20,000. So we got 0, and then we got 20,000. And notice that this is a quadratic that opens down. And so we know that the vertex is going to happen in the middle of the intercept. So it's going to happen at 10,000. Right, so the vertex is going to be up there. Right, so notice that we got that 10,000 in two different ways, figuring out when the marginal revenue is equal to 0, and then also figuring out the location of the vertex of the total revenue function. And so it would look something like that. And then if you wanted to get that actual maximum revenue there, you could take that 10,000 and then you could plug it into the revenue function, and then you would actually end up getting 4 million. So when 10,000 units are sold, then the revenue is maximized at 4 million. And then after that total revenue starts going down. Right, so that's how you could use, that's another use for the marginal revenue, is finding the location of that maximum revenue spot. And it's basically when the marginal revenue is going to equal 0. Another use of marginal revenue, we're not going to go into detail on it in this video, but we will in a future video, is you can find out when does the marginal revenue equal, you could compare it to the marginal cost. And when the marginal revenue equals the marginal cost, this is when profit is maximized. So we're going to go into detail on this in a future video. But remember, profit is different than revenue. Profit is equal to revenue minus costs, right? Total revenue minus total costs. So it's different than just revenue. So revenue is maximized when the marginal revenue is equal to 0, but profit is maximized when the marginal revenue is equal to the marginal cost. So that's another use for the marginal revenue function, is comparing it to a marginal cost function. So you can see when profit is maximized. Again, we won't go into detail on that in this video, but thought I would mention it. All right, so that's pretty much it for the video. Hopefully that helped you understand a little bit more deeply about how revenue and marginal revenue functions relate.